Okay, so welcome back to 9.9. We were working on this example in class in the notes, so you should have your notes handy, and you're going to be recording here. So I just want to remind you that there was a typo right there. That was a plus, but it needs to be a minus. Otherwise, we end up with a very strange problem indeed. Okay, so we have our equations here numbered 1, 2, and 3. We're going to start by choosing any two equations. So I had chosen in class equations 1 and 2. Okay, and I line these up. X plus y minus z equals -1. I line that up with 4x minus 3y plus 2z equals 16. Okay. Alright, and then I had wanted to multiply to get rid of z, so I'm going to double this equation here. And this makes my system 2x plus 2y minus 2z equals -2. And then 4x minus 3y plus 2z equals 16, which I can then use this system to add and eliminate z from the problem. So I end up with 6x minus y equals 14, and you want to hang on to that. Okay, now you choose a different pair. So choose another pair. So let's do 1 and 3. I don't remember if that's what I picked in class, but this will work. Okay, so we have x plus y minus z equals -1, and 2x minus 2y minus 3z equals 5, and I'm going to multiply my first equation by -3 this time. So my system is -3x minus 3y plus 3z equals 3. And that lines up with 2x minus 2y minus 3z equals 5. Notice that I'm trying again to eliminate z. So if I add, I get -x minus 5y equals 8. And I'm going to be using these two equations. That's the first one I circled there. Mathematically, we would call that one of the linear combinations of equations 1 and 2. And then this one I've circled at the bottom is a linear combination of equations 1 and 3. Okay, so now we'll take these two equations together, and we will use them to do a simple combination as well, elimination method. Okay, so let's put those together. So I'll do my work over here in blue. So now I'm going to take 6x minus y equals 14 alongside with -x minus 5y equals 8. And I'm going to use this to eliminate y. So I'm going to multiply my first equation by -5. And this gives me -30x plus 5y equals -70. And I can line that up with -x minus 5y equals 8 and add. I get 29x equals -62. Sorry, that was a -30, so this is a -31. I just couldn't read my own handwriting there. Let that be a lesson to us all. Okay, and from here we can see that x is simply 2. Okay, once you have one of these figured out, life is pretty easy. Go ahead and take your x equals 2 and substitute it into one of your equations that you found earlier one of these simpler ones. Don't go back to the very beginning. Don't go up to these yet. Okay? Okay, so let's just go with, our first one. Okay, so we're going to go with this one here. It's 6x minus y equals 14, and x is 2. So it's 12 minus y equals 14. And if you solve that, you end up getting y equals negative 2. Okay, so now we can go all the way back to the very beginning and use one of the equations that we started with at the very top. Out of these three, probably the simplest one is the first one. So this is the end, the grand finale now. We have x plus y minus z equals negative 1, remember, from the beginning. Copy that over a little bit. X plus y minus z equals negative 1. Still can't get that to fit. And we have the numbers 2 plus negative 2 minus z equals negative 1. These cancel out, and we end up with z equals 1. Okay, our final answer should fit nicely right in the corner here. 2, negative 2, 1. Our ordered triplet. And remember, this is a place where the three planes intersect in space. These are three planes. Okay, let's take a look at the next page. Okay, so our next example, example 2, you'll notice that some of this is, like there's some space in between here, between the 2x and the z. That's just because there's no y for that line. And then this third equation has no x. So if you wanted to, I suppose you could put in like a 0y here and a 0x here. It's not really necessary for what we're doing. Later on we'll talk about when to put zeros in. I'm not going to actually write those in. Let's just begin. Okay, so let's say I pick the first two equations again like I did last time. And I say x plus y plus z equals 5 and 2x plus z equals 8. I can multiply that first equation or the second equation by, let's say, negative 1. Let's do this equation by negative 1. Okay, so I have x plus y plus z equals 5 and negative 2x minus 2, or excuse me, minus z equals negative 8. Okay. Okay, so adding these, I get negative x. There's a plus y in the first line, and then z cancels out. I get negative 3. Okay, so that's kind of stage 1, right? Okay, then I need to do the same thing and eliminate the same variable from a different pair of equations. So I'll just pick the first and last ones like I did last time. I think that's what I did last time. Anyway, it doesn't matter. Let's pick the first one and the last one. So that's the 3y plus 2z equals 5. Okay, let's multiply the first equation by negative 2. Sorry about that. And we have negative 2x minus 2y minus 2z equals negative 10. And then we have let's line this up properly. 3y plus 2z equals 5. Add this together. Okay. So we end up with negative 2x plus y. The z's cancel out, and we get negative 5. Okay, let's take our two equations again, like we did last time. so that's a negative. And that one and this one. And we'll bring those over to here and work on it. Okay, so we have negative x plus y equals negative 3, and negative 2x plus y equals negative 5. Can multiply the first equation or the second equation by negative 1. Let's do the second equation. Okay, and our system is negative x plus y equals negative 3, 2x minus y equals positive 5. We can add those and we get x equals 2, right? Okay, now let's go back and let's plug that into this equation here, because this one has an x in it and a z. Alright, so here we go. So we would say, alright, 2x plus z is 8. And we just discovered that x is 2. So it turns out that 4 plus z equals 8, and z equals 4. Alright? And then going back to the first equation, x plus y plus z equals 5 from the very beginning, or you can use the third equation, might be easier. We can just plug in the 2 and the 4, and we end up with y equals negative 1 as a solution. So we have again a consistent system. This time our solution, I'll put it in red at the very top, was 2, negative 1, 4. Okay, now just a quick reminder that some problems don't actually have a single solution like these ones have. I know it looks like we're getting 3 answers, but each time you write down an ordered triple, that's actually one solution, a single solution. Okay, some systems may have no solution. Some systems may have infinitely many solutions. Remember the scenario with the lines? You can have 2 lines that cross once. You can have 2 lines that don't cross at all. Right, no solution. Or you can have 2 lines which are actually the same line. Maybe the 2 equations looked different, but they were really the same equation in disguise. Okay. Let's look at our next page here, and we'll see the scenarios for the plane. We talked about this in class 2. Okay, actually, we're going to just move on here to example 3. Okay, something very interesting happens with this one. You'll notice sometimes you get yourself in a situation where it's, something strange might happen. This happened with lines too, but let's take our first and second equations again, and let's go ahead and add those. Actually, we'll multiply them. So this is my first equation. I'm going to go ahead and multiply my second equation by negative 1 right off the bat. It's negative x minus 2y plus z equals 9. So hopefully you can see why I would do that. I'm trying to eliminate my z again. We get x minus y equals 7. Okay, let's take the first and third equation. The first equation is 2x plus y minus z equals negative 2, and the third one is x minus 4y plus z equals 1. And adding these, we get 3x minus 3y equals negative 1. And let's take these 2 equations. Both are lacking the z, so they should work together nicely. And we have x minus y equals 7, and 3x minus 3y equals negative 1. Let's multiply the first one by negative 3. We end up with negative 3x plus 3y equals negative 21, and 3x minus 3y equals negative 1. And adding these gives us 0, because both x's and y's cancel out, equals negative 22. Now this is nonsense, and so this is an example of a no solution problem. Okay, let's look at our next example. So there are a lot more things we could talk about with the infinitely many solutions. In Algebra 2 honors, we're really just talking about solutions themselves. We're not getting too deep into systems. There will be more to say later about this scenario on this last problem, and how to write out dependent systems like this using particular solutions. So we're not going to do that. We're just going to call this infinitely many solutions and call it a day.